Welcome back. Today is day 3 of our similar triangles unit. We will be defining similar triangles and determining if triangles are similar. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Go over this do now. It says the Los Angeles Dodgers have won 6 World Series titles in the last 62 years since they have been playing, starting in Los Angeles. At this rate, how long will it take them to win 10 World Series? All right, perfect. So a lot of our problems in real life are going to be ratios and proportions anyways. So here we go. Let's go ahead and try to solve this problem. So what do we have? So we can write a ratio with wins and number of years. So this is what our ratio is going to be. So we're going to write how many wins they have, how many World Series title wins they have, and the number of years they've been playing. So in this problem, we're going to say, okay, well, they've won 6 World Series titles. It took them 62 years. And our question is going to be, what do we want to know? How long will it take them to win 10? So we want the wins to be 10, and X will be what we're trying to figure out. We're trying to figure out what is 10. So remember what we did the other day. This is just a proportion now, and now we can solve it by finding the product of the means and the extremes. So my means will be these ones, and my extremes will be these ones. So let's find the product and figure out what that is. So that's going to be, I'll write it out again, long way. So 62 times 10 is equal to 6 times x, which is 620. And 6x. So then it's just a basic algebra problem. So you're just going to divide it by 6 on both sides of my equation. And x is approximately what? What is that? What is 620? Let's see if I can do that real quick. 620 divided by 6. And about 103 years. So 103 years. All right, perfect. So before they win their 10th one, it'll be 103 years. So maybe I'll still be alive by then. Let me see. Got 40 years left. Yeah, I might be able to make it. All right, here we go. Let's go with the next problem. So remember that dilation activity we did the other day. So we messed around with GeoGebra. We did a dilation activity, and here's the big ideas. So what we were trying to learn from this activity was 2 main concepts. So here we go. Let's summarize it in a definition. So 2 polygons are similar. So they're similar polygons. All right, if something happens, and what do we learn from activity? So when we dilated these triangles, we learned 2 things happen. So number 1, the corresponding angles are congruent. So number 1, this was the first thing that we needed to learn. So if you notice, look at these triangles. So this angle here is the exact same as this angle here. And if we look at this angle over here, it was 71 degrees, 71.6. So is this one. And if we notice this one, these were all the same. Okay, so that was the main idea, one of the main ideas that we were supposed to learn about similar polygons. So when we dilated these shapes, we got bigger and smaller shapes, but the angles stayed the same. And the second big idea was the corresponding lengths are proportional. So obviously these sides are not the same size, but what we figured out is that this side here was similar. I'm going to put like a little S to this side. So this side was similar to this one. This side is similar to this one. So meaning that the ratios were the same. And you can see that we have here a bunch of ratios written out every single time. So we wrote out the ratio, we wrote out the ratio, we wrote out the ratio over and over again. And what we were saying was the corresponding sides, so like whatever side corresponds to AB, well, that would be DE, those ratios would be the same. All right, so that was one of the big ideas that we learned from the activity. So those are the 2. All right, so let's use those now. So what do we have to know about that? So this just summarized the same thing. This says the exact same thing. So in the diagram below, ABC is similar to EFG, H. So this polygon here is similar to this one. All right, so then we should know two different things. First of all, the corresponding angles will have to be the same. So for instance, in this problem, A is going to correspond to E. So those are going to have to be the same. So I'm going to say angle A is congruent to angle E. Okay, and the cool thing is you can also look from up here at the letters. So A and E are in the first location. So we know that those have to be the same. All right, the next one that's going to be the same. Well, B is the same as angle F. So angle B is congruent to angle F. And if you look up in the picture there, B is in the second location, so is letter B is in the second location, so is letter F. They have to be written that way. They're going to be in the same order. All right, so then we can continue on. We have that one. Let's say C now. So C is current. These are going to be the same angles. So angle C is congruent to angle G. And lastly, angle D will be congruent to angle H. So that's what we're supposed to learn. So we're supposed to, if things are similar, if polygons are similar, the angles will have to be congruent to each other. But now the sides are different. Sides are a whole different story. These are going to have to be proportional. I'm going to write that one more time. So these are proportional. All right, so what do we mean by that? We mean all the ratios are going to be equal. And you can use the same kind of format to figure this out. So AB, let's go with this piece here. AB is the ratio from that to this is going to be the same as all the other ratios. And you can use the same idea up here. So AB, and a lot of my students have trouble with this, but AB and EF have to go together. So those are going to be corresponding. So you see how you can use just that similarity statement at the beginning to figure this out. So AB corresponds with EF. And that has to be equal to all the other ratios. So then we have to say BC corresponds to FG. So that's just saying this piece out here, here's BC, is going to correspond with this piece here. And those ratios will have to be the same. And then to keep going, so CD is corresponding to GH. And lastly, AD to EH. Okay, so all we did was say all the sides, we know they're not equal. They could be equal, but they're not equal. They're going to be proportional. Not every single time. Every single time they'll be proportional, but every once in a while they will be equal if they're both equal to 1. All right, so let's move on to the next problem. Shortcuts. So we'll explain this more as we do the problems, but there are going to be 3 main shortcuts that we'll use to tell if triangles are similar. Because there's no way I want to say check all the angles to make sure that all the angles are the same and to make sure all the sides are the same. So there's going to be 3 shortcuts. The first one is called AA. Let me just sketch a picture. So if you have a triangle and another triangle, and what it says, if 2 angles are the same, like this pair and this pair, if 2 are the same, then guess what? These are similar triangles. All right, so all we need to show is that 2 of the angles in these triangles are congruent to each other, then we know that they're similar. Okay, we don't need to actually say all the sides either. These are the shortcuts. Now, what about for this little problem here? This one's the annoying one. This is the one that takes a lot of work. So side, side, side means you're going to be comparing the sides, which means you need to show that this side and this side and this side and this side, and lastly this side and this side. So really we need to check to make sure all the sides are proportional. So what we're going to have to do is check to see, let me just make up some letters, AB, BC, and AC. Let's go with XY, YZ, and XZ. So here's what you're going to have to do. You're going to have to check all of these. You have to check every single ratio to make sure they're equal. And then you can say, yes, they're similar because of side, side, side. So that's what you're going to have to do. This is an annoying one. This one takes a while. This one takes a little bit of time to use. And the last one is kind of a combination of angles and sides, but in this one, let me sketch out the picture for this one. And I bet you kind of figure already what you need to show. So on this one, we'll have to have an angle. And this angle needs to be between the two sides that you're going to be showing. So like this one here. So we need to have one congruent angle and then two pairs. So you'll only actually have on this one two ratios, like AB and BC corresponds to XY and YZ. Okay. And I don't have letters labeled there, but you'll see as we go. So again, the two that we use the most are 1 and 2. You need to show two angles the same, or you need to show all the sides are proportional. And every once in a while, we'll try number 3 also. So let's go with a problem. Let's try some. So number 1, are these triangles similar? Well, if they are, write a similarity statement. So first of all, there's no sides given. So really that means I probably should do some math here and see if the angles are the same. And I see that they both have a 90. So they both have a 90, so we know one pair of angles is the same. All we need is another pair, and we could say these are similar. And let's do a little math and figure out what the missing angle is. So we know that triangles equal 180. So you can figure out what this missing angle F is, and that's going to be, it's actually 42. Do a little math, figure out what that is, but that's going to be 42. And so what I see now is that we have the 90-degree angle, and we have this 42-degree angle. So we have two pairs of angles. So what does that mean? So that means, yes, these are similar by angle similarity. All we needed was to show that two pairs of angles were equal to each other, congruent to each other, and then we know that these are similar. And then we'd have to write a similarity statement. So when they say write a similarity statement, they just means tell us what triangles are similar. So triangle, let's go with FHG is similar to, now remember they have to be in the same corresponding order. So if you say FHG, then you need to name the other triangle starting with the other one with K, and then we go down to the 90, which would be J, and then we go over, so L. So this is how you write the similarity statement. So when they want a similarity statement, that's what they're asking for. They're asking for that. All right, so that's all you're going to be doing is saying, okay, looking at some triangles and determining if they are similar to each other. Let's try problem 2. So this one has 3 pairs. So we're comparing everything. It says either triangle DEF or GHJ similar to ABC. So this is the one we're going to compare to. So is this one similar, or is that one similar, or are both of them similar? So again, this is where it gets a little bit annoying. All right, you're going to have to check all the sides. So let's try the first pair. Let's try the first triangle. I'll do it on top so we can see it, but we're going to compare 8 to 6. So what I'm doing is comparing 8 to 6, and then I'm going to go with the next smallest one. Let's go with the 12 and the 9. So the 12 and the 9, is that the same as this? And the last one is, what about the 16 and the 12? Are these all the same? Because if those are the same, guess what? The triangles are similar. So let's see. I think you can reduce the 8 over 12 to, let me just rewrite this. So we can reduce the 8 over 12 to 4 over 3. So just divide both sides by 2. We can reduce the 12 over 9 to 4 over 3. Just dividing by 3 on that one. And the last one, we can reduce the 16 to 12 to 4 over 3. So guess what? All those ratios are the same. So yes, they're similar by side similarity. So that's what we mean. We've checked all the corresponding sides and the ratios are all equal. So that's what side means. All right. And the last one is probably a no. Let's go ahead and figure this one out. Let's see if that works. I'm just going to use one color. How about 6 oh, sorry, we're still using the first triangle to the third one. So we're going to go with 8 to 8. And then a 12 to a 10, and then a 16 to a 16. And we can see right here, this is the problem. All sides are not proportional because 8 over 8 is 1 and 16 over 16 is 1. This is the problem. So this is the problem with this one. So this is no, not similar. All right, and that's all you're doing. Okay, so that's side, side, side. The other one's angle, angle. You'll have a few more of these to try. Let's go ahead and try a few more. Like this one. This is a nice, simple one. Determine whether triangles are similar. If they're similar, write a similarity statement. Well, there's no sides given, so this looks like it's going to be the easier one. We already have a 45, and we already have the 45. We just need one more pair. Well, there's no other angles given, but hopefully you remember from earlier this year that these two angles have to be the same because those are vertical angles. Remember, vertical angles are always congruent to each other. So guess what? Now we have two pairs. So yes, they are similar by angle, angle similarity. That's all we needed to show was two pairs of congruent angles are similar. And then they want us to write a similarity statement. So this is the part that gets a little confusing. So let's try the first one. N, Y, M is similar to. So if I started with N, I need to go over to the other triangle and start with Z. So we'll go with triangle Z, and then I went to Y. So then I'm going to go to Y also, and then I went to X. Okay. So there would be my similarity statement. So remember, when they want a similarity statement, this is what they're asking for. So when they say, hey, write a similarity statement, they're asking for this. All right, last problem, and I think we're going to be done with this. Are these two triangles similar? Well, we're going to have to do a little math again. We know the triangles add up to 180. Let me do this one here. So 65 plus 35 is 100. And that means that this angle must be 80. And I can see right now I do have one pair of angles. I have the 35, but I will not have another one because I should have either 85 right now, but I have 80 and 85. So guess what? These are not similar. So that's going to be your job. Your job will be looking at these to figure out, are they similar or are they not? Oh, I guess there was one more. And the last problem, are they similar? Well, guess what? You have this angle and you have this angle. You just need one more. Well, it can't be D and E. We don't know that yet. I mean, you could actually say that if you did a little bit of proof here. But the one that was obvious is the one that's right here is C. Both triangles share C. So C is in both triangles. So guess what? The answer is yes. AA similarity. And we would say triangle. Let's start with the small one. BCD is similar to triangle ACE. All right, so that's it. That's all we're going to be doing. Find two angles that are the same or check and basically see if all sides are proportional. All right, good luck. And for your closing today, I want you to give this a shot, see if you can complete this statement. There's a link to where we got it below, and good luck with it.